Welcome to today's lecture. So today we're revising trigonometry because we're about to start complex numbers, which involves a lot of trig. Then from complex numbers, we'll go direct to calculus. And calculus also requires you to at least have a strong background when it comes to trig. Okay, so we'll just touch cardinal points. We'll not do everything in trigonometry. We'll just touch points which are very important. So imagine that you've been given, for instance, to find the sine of 30 degrees or the cos of 30 degrees, or maybe tan 45 degrees, or sine 60 degrees. How can you find this without using a calculator? So this is where we're going to begin from, because I was okay. I never felt nice when I saw that almost everyone, except for one person, managed to find. I think that was cos 150 degrees. That's why I've even decided to go back to trig. Yeah, so you'll not be allowed to use calculators, so you just have to know how to find these. Yeah. All right, so let's quickly begin. Let's see how you can find solutions of special angles. So first of all, I'll draw a certain table here that you just have to master how to draw it. So first thing, I'm going to write numbers starting from 0. Okay, let me write the angles first. So I have the angles 0 degrees, special angles, 30 degrees. Then we have 45 degrees. We have 60 degrees. We have 90 degrees. These are the most important special angles that we have. Then I'll write numbers starting from 0 up to 4. 3, and then 4. So from there, I'm going to find the square root of all these numbers. So square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. Let me now find the answers of this. So the square root of this will give me 0. The square root of 0 is 0. Square root of 1 is 1. Square root of 2, that's an irrational number. You leave it like that. Same applies to square root of 3. It's also an irrational number. We can leave it like that. Then square root of 4 will give us 2. Then from there, we can divide everything by 2. So now let's find the answers. 0 divided by 2, the answer is 0. And then 1 divided by 2, we just leave it like that. The root of 2 divided by 2 is just the root of 2 over 2. It's also an irrational number. And then the root of 3 divided by 2, it's also an irrational number. And then 2 divided by 2, the answer is 1. So the answers that we have found here, these are solutions of sine theta. So this is our theta. This is our theta. So when you say sine 0, the answer is simply just 0. When you say sine 30, the answer is simply just half. Sine 45, the answer is root 2 over 2. Sine 60, the answer is root 3 over 2. Sine 90, the answer is 1. Then from there, let us find for cos. So for cos, we're just going to write these same numbers here, but we'll start from 1. We'll start from this side from 1, and then going this side. So we'll start writing these numbers starting from 1, going this side, but we'll bring a 1 here, and then followed by root 3 over 2, which is going to be there, then followed by root 2 over 2, root 2 over 2, then followed by 1 over 2, 1 over 2, and then lastly we write 0. So cos 0, the answer is 1. Cos 30, the answer is root 3 over 2. And then cos 45, the answer is root 2 over 2. And then cos 60, the answer is 1 over 2. Cos 90, the answer is 0. Now let us find tan theta. So we know according to trigonometric identities that tan theta is simply just equal to sine theta over cos theta. So it's simply just sine theta over cos theta. So meaning when you divide these numbers that were found, the values of sine and cos, when you divide them, the answers that you'll be getting, the answers are the solutions for tan theta. So 0 divided by 1, the answer is 0. And then half divided by root 3 over 2, the answer is simply just 1 over the root of 3. And then root 2 over 2 divided by root 2 over 2, the answer is 1. And then root 3 over 2 divided by 1 over 2, the answer is simply just the root of 3. And then 1 divided by 0, the answer is undefined. So these solutions that were found here are simply the solutions of tan theta. So this is how you come up with the table for special angles. So we have tan theta, which is tan 0, the answer is 0. Then you have tan 30, the answer is 1 over root 3. Then we have tan 45, the answer is 1. Tan 60, the answer is root 3. And then tan 90 does not exist, it's undefined. All right, so this is how you find solutions of special angles. So this is the most important table that you need to know. Okay. 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 So this is simply, these are the solutions of the special angles. All right, so let's quickly move on. Do we have questions on this before I proceed? This is straightforward, of course. Yeah, so if you missed how I've come up with this, I'll send the link in the group. You watch, I think I've made a video on just how to do this. Then apart from that, even this video, I'll send a link on the group. So this is what I was just talking about. So let us also look at SOHCAHTOA. I'm sure most of you have not forgotten what SOHCAHTOA is. So SOH for so, which is from SOHCAHTOA, means sine x is equal to the opposite over the hypotenuse. Ka, which is cos x is equal to adjacent over hypotenuse. T, which is tan x is equal to opposite over adjacent. And then that comes from a right angled triangle. Yeah. So let's move on. So let us also let us also revise trig ratios with their quadrants. So this is an XY plane showing quadrants. This is an XY plane that is showing quadrant in trig. Yeah, so this part here is called the first quadrant. This one is the second quadrant. So what is the region between 0 degrees and 90 degrees is the first quadrant. Then from 90 to 180, that's the second quadrant. From 180 to 270, that's the third quadrant. From 270 to 360, that's the fourth quadrant. Okay, so in the first quadrant, we know that all trig ratios are positive. Yeah, so all trig ratios are positive in the first quadrant. And then in the second quadrant, only sine theta is positive. And then in the third quadrant, only tan theta is positive. And then in the fourth quadrant, only cos theta is positive. Yeah, so this is a very important part of trigonometry. Okay. So this is what I was just talking about. Sine theta is positive, tan theta is positive, and lastly, cos theta is positive in the fourth quadrant. Then apart from that, you also have to understand that in the first quadrant, when you're solving trigonometrical equations, if the trig ratio is in the first quadrant, then you get the value of theta. Just get, if theta is 30, you get the value of the reference angle. If if I've put any question down, I will look at it. Then in the second quadrant, you say 180 degrees minus the reference angle that you found. And then in the third quadrant, you say 180 plus the reference angle that you found. And then in the fourth quadrant, you say 360 degrees minus the reference angle. Okay. Okay, so this is what I'm just talking about. Okay. So, all right, so this one is repeating. Okay. All right, so let's try to solve these questions. These questions are just big angles that you can't just solve by looking at them, but at least you have to use some of the concepts that I've explained. The question is, find the exact values. Do not use a calculator or any table. Find the exact values for the following. The first one is sine 25, sine 225. So sine 225 degrees. This, first of all, we can find a special angle that this number is very close to. Yeah, so the special angle that this number is very close to is simply just 180 degrees. So we're going to say, if this number is bigger than 180, we're going to say 225 minus 180. The answer that you get is 45 degrees. So sine 225 is just the same as sine 45 degrees, but we're not supposed to end here. We have to look at the quadrants. So we know that 225, if this is 180 degrees, that is 90 degrees, this is 0 degrees, and then this is 270 degrees. We know that if this is 180 degrees, angles move from the positive x-axis going anti-clockwise. So if this is 0 degrees, this is 180, it means that 225 is somewhere there. If this is our angle, so meaning 225 degrees is somewhere in the third quadrant. So in the third quadrant, we know that it's only tan which is positive, meaning sine in the third quadrant will be what? Will be negative. So we just add the negative that side. So we know to say sine 45, according to that table of trig ratios, is simply just the root, the table of special angles. Sine 45 is simply just the root of 2 over 2. And of course, we don't forget to put the negative. That is how simple you find that. It's very simple. So now let us also look at cos 150, the one which everyone almost failed. So cos 150 degrees is equal to, so let us look at the angle, the special angle that 150 is very close to. So 150 is very close to 180 as well. So we're going to say 180 degrees minus 150 degrees, which gives us 30 degrees. So cos 150 is simply just the same as cos 30 degrees. Now, let us check 150. Where does 150 lie? Is it in the first, second, third, or fourth quadrant? So we can draw the quadrants there. We have the 0, we have 90 degrees, we have 180 degrees, we have 270 degrees. So 150, if this is 90, this is 180. It means that 150 is somewhere there. So 150 is somewhere there. Okay, so if this is 150, this is 150. Let me just draw it properly, at least it should be reasonable. Okay, so 150 can be somewhere there. So if this is 150 degrees, this is 150 degrees, it means that it's in the second quadrant. And then we know that in the second quadrant, only sine is positive, only sine theta is positive. But in this case, we have cos, meaning cos in the second quadrant is what? Is negative. So the answer will be negative cos 30 according to the table of special angles. It's simply just the root of 3/2. So this is how simple these angles are. So the same applies to the part when you've been given an angle that is in radians. So what you simply do is that you just have to convert this to degrees Celsius. And in case you've forgotten how to convert this, you say pi in radians is equal to 180 in degrees Celsius. So pi in radians is equal to 180 in degrees Celsius. So we have 2 pi over 3. This one we don't know, it's the one that we're looking for. So you just put x there. So we cross multiply there, we're going to have x pi is equal to, this times that, we're going to have 2 times 180 degrees over 3 pi. So of course this pi and that pi will cancel. We just remain with x is equal to, and then 3 into 3, 1, 3 into 18, 6, and then you add that 0. And then so 2 times 60, we have 120 degrees. So now let us, so in other words, sine 2 pi over 3 is just the same as sine 120 degrees. So sine 120 degrees, we know that 120 is in the second quadrant. 120 is in the second quadrant. So if 120 is in the second quadrant, and we know that sine in the second quadrant is positive. Yeah, so sine 120 degrees, sine 120 degrees is simply just the same as, so if you want, you can use, okay, so we can use 180. Yeah, let us use 180. So we say 180 minus 120, the answer is 60. So this is just the same as sine 60 degrees. Yeah, it's the same as sine 60 degrees, which is just sine 60 is simply just the root of 3/2. So this is simply how you find the special angles. I don't know if you have any questions before we proceed. So tan 330 is just the same. You can use 300 to subtract 330, and then 420 you can also use 300. 300 minus, oh, this one is what's this? It's a very big angle, so you just use its terminal angle. So the terminal angle for 420 is simply just 360 degrees minus, oh sorry, 420 minus 360 degrees, which will give you something like, okay, we say 420 minus 360. 420 minus 360. This is 60 degrees, yeah. So you have 60 degrees. So the terminal angle for 420 is simply just 60 degrees. So sec 420, sec 420 degrees is just the same as sec 60 degrees. And we know to say sec 60 degrees is just the same as 1 over cos 60 degrees. So cos 60 degrees is a known angle, which is just 1/2. So cos 60 is 1/2, which, so when you divide there, the answer will just be 2. Yeah, same applies to this one. This one, despite it being negative, it's still solved in a similar way that I've solved this. So even 300, I mean negative 135, negative 135. So for negative angles, instead of going this side, means that you're going in the opposite direction. You're moving 135 going back. So 135 will simply find itself somewhere there. Okay. So let's proceed. Find the exact values without using a calculator or a table. So let's look at this one. I don't know if I've skipped something, but I think I've skipped something. Yeah, okay, let's find sine 15 degrees. So before we solve this question 18, there's something that I want us to learn first. Okay, not really double angles. I think I've skipped something. I didn't put something in this. Yeah, there was something that I was supposed to put. Anyway, let me just explain what I was supposed to put. Okay, okay. Let me just explain here. So what I wanted to put is simply just, you should understand to say sine A plus B, compound angles in short. A plus B is equal to sine A cos B plus sine B cos A. So simply just switch the angles. If sine is the one that had A this side cos A is the one that will have A. And then for cos, you have cos A plus B. Cos A plus B is equal to, you have cos A cos B minus sine A sine B. Then you also need to understand that you can also have sine A minus B. So sine A minus B simply just be found by changing the sign in between them. The rest remains the same, sine A cos B minus sine B cos A. And then for cos, we also just change the sign. Cos A minus B will just simply be cos A cos B plus sine A sine B. So these are the equations that I forgot to put in the slide. Yeah, so they are very important. They are the ones that we're going to use to solve these questions here. So let us start. Hope you've copied them somewhere. So sine 15 degrees. So sine 15 degrees. So sine 15 degrees can also be written as what? We can use two angles, two special angles that we know. If we add or subtract them, they'll give us 15 degrees. So which two special angles are those? When we add them, or maybe if we subtract them, they'll give us 15. So I think it's 45 and 60. So we can say 60 degrees minus 45 degrees can give us 15 degrees. So we say sine 60 degrees minus 45 degrees. The answer will be, using those equations that I wrote here, we can just say sine 60, then cos 45, times 60 cos 45, then minus sine 45 degrees cos 60 degrees. Then from there, sine 60, we know that it's the root of 3 over 2. Then we're multiplying it with cos 45, which is root 2 over 2. Then minus sine 45, which is also root 2 over 2, times cos 60, which is 1 over 2. So here it's just a matter of multiplying them. So when you multiply this times that, we get root 6 over 4. Then minus, this will give us the root of 2 over 4. So since the denominators are the same, means that we're just going to add the numerators. So we have root 6 minus root 2 over 4. That's the answer. So the answer for sine 15 is simply just root 6 minus the root of 2 over 4. So sine 15 degrees is simply just equal to this. So this is how simple you find angles that are not special angles. Yeah. So I don't know if you have any questions. So for cos, you just use the identity for cos, the compound angle identity for cos, this one here. So first of all, you convert this angle to degrees Celsius, and then use you find two special angles that are going to give you that angle that you're going to find. Yeah. So we know to say pi over 15, pi over 12, when you convert it to degrees Celsius, this is just the same as 15 degrees. So cos pi over 12 is simply just the same as cos 15 degrees. So you find two special angles that you are going to add or subtract to get 15 degrees. Which are those? You can use the same ones that we used here. This is cos 60 minus 45. The previous slide have we erased? You mean where I wrote the, you can just unmute yourself. You mean where I wrote the, what's this, the compound angles?
Yes.
I erased them. Just tell me that I rewrite them again. Anyway, they are there. They are there in front. I think I had put them somewhere when deriving the formulas for half angles and double angles. So I'm sure you'll see them. I'll be telling you that. Huh?
All right.
Yeah. So this is how simple you find solutions of non-special angles. Okay. So let's look at double angles. So this is one of them. Miriam, this is one of the identities you wanted to say, to see. So you have sine A plus B is equal to sine A cos B plus cos A sine B. So now imagine that while there's B, we put A. We say, what if A is equal to B? So meaning while there's B, we put A. What are we going to have? So we're going to have something like sine A plus A, which will just also be equal to sine A cos A, then plus sine A again cos A. So when you look at these two terms, they are like terms. So now since these two terms are like terms, you can easily add them. So sine A plus A will give us 2A. So sine 2A is simply just going to give us 2 sine A cos A, 2 sine A cos A. That is what we're going to have. And then same applies to the one for cos. If you have cos, the one for cos is simply just cos. A plus B is given by cos A is given by cos A cos B, and then minus sine A sine B. Now, if you have this, now we also assume that, or we take for instance, if A is equal to B. So if A is equal to B, we're going to have something like cos A plus F, which will give us cos A plus A, which will give us cos A minus sine A sine A. So cos A plus A will give us 2A. So we have cos 2A is equal to cos times cos, we get cos squared A. Then minus sine times sine is equal to sine squared A. So these two equations that I've found, this one here and this one there, these are called double angles. These are double angle formulas. So this one can be manipulated, this one. We know that according to the Pythagorean identity, which is sine squared theta plus, or let me use sine squared A plus cos squared A is equal to 1. According to this, we can make cos squared A the subject, which will become cos squared A is equal to 1 minus sine squared A. So while this cos squared A, we can put sine squared, we can put 1 minus sine squared K. I mean A in this equation. So at this point where there is cos squared A, we can replace with this part here. Yeah, so I think I've solved everything in the slide. This is what I was just explaining. So sine 2A is equal to 2 sine A cos A. It's a double angle formula for sine. So to find the half angle formula for sine, I didn't talk about the half angle formula, but it's straightforward. It means that you are dividing this 2A. So this one is called the double angle formula for sine. There's also what is called the half angle formula. So the half angle formula for sine, we divide all the angles in the expression by 2. So when you divide this 2A by 2, we'll get A. And even this side, we'll do the same. We divide the angles by 2. So you're going to have something like this. It's also one of the very important expressions you need to know. So sine A will simply just be given by 2 sine A over 2 cos A over 2. It's very important. Okay. It's called the half angle formula for sine. All right, so let us look at the one for cos. So Miriam, you're the one who wanted to see these double angle, these compound angle formulas. So this one is the one for cos. Yeah. So we also assume that cos A, we also assume that A is equal to B. So we're going to have cos A plus A is equal to, while there is B there, we'll be putting A. So when you put A there, we'll get something like that. Then from there, cos 2A will simply just be cos squared A minus sine squared A. So now we can use the Pythagorean identity, which is sine squared A plus cos squared A. And then we make cos squared A the subject. We're going to have 1 minus sine squared A. We're going to have this. Then from there, we replace it where there is, we replace cos squared A here. This one there, we replace it there, meaning we're going to get what is this side and put it there. So when you put it there, you get something like this. Yeah, so you get something like this because this negative sign and that negative sign can add to get negative 2 sine squared A. That's what you're going to get. So this is also one of the important what's this trig identities that you need to know. Cos 2A is equal to 1 minus 2 sine A. So same applies when you get, when you make in this Pythagorean identity. Now you make sine squared A the subject, meaning you have something like sine squared A is equal to 1 minus cos squared A. And then while there's sine squared A, there, you replace with 1 minus cos squared A. You're going to get something like this. So this is what you're going to get because you have cos 2A is equal to cos squared A. Then you say minus, you put this 1 minus cos squared A. And then you simplify it to bring you to something like this. This is what you're going to get. So these are called double angle formulas for cos. Then the half angle formulas for cos are as follows. This one here and the other one there. Okay, so these are the half angle formulas for cos. Yeah. So do you have questions up to this point before we go to time? Okay, so this is straightforward, I guess. All right, so tan theta, tan A plus B, you also have to master this. You will not be given anywhere. So tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. Tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B. Okay, so this is the double angle formula for tan. When you say A is equal to B, meaning while there's B there, you just put A. This would be A plus A, so meaning this will become tan 2A, which is just there. And then on top there, you're going to have tan A plus tan A, which gives you 2 tan A. Then down there, you have tan A times tan A, which will give you tan squared A. You have this as your double angle formula for tan. Then the half angle formula for tan will be given by that. You just divide all the angles by 2. All right, so there is this question here, which I believe they can't give you this question. I just mistakenly put it here because it was supposed to be given to you last semester when you did trig. Yeah, this is just a simple question that you can try to do on your own. Yeah. Okay. Actually, I've even solved it already in the slide, so you just go through it when I send the slide. All right, find the exact values for sine theta over 2. Here you just get one of those half angle formulas and use it to find these answers. Just as simple as that. All right, so trigonometric identities, I'm sure you know them. When you divide everything by sine using the Pythagorean identity, you divide everything by sine, you get this, and then your answer will be that. You know that cos over sine, the answer is cot. 1 over sine, the answer is cosec. Sine over sine gives you 1. So this is straightforward. So I just wanted us to revise through trigonometry, more especially the part of finding what's the solutions of bigger angles, like maybe cos, like the one that we did, cos 225, cos 300. Maybe for instance, if you've been given something like sine 150, sine 330, then that's the most important part I wanted us to revise, because it's very important on complex numbers. You need to know how to find this. So you can find time to revise through all this. Yeah. So I'll send an exercise at the end of this. Let me just go to the last slide. We're in the last 1 minute. If you have any questions, you can ask, but I'm sending the slide immediately after this. Yeah, so all these, you need to know them. They are very important. They are very important identities that you need to know. Okay. All right, thank you very much for attending tonight's lecture. See you in the next lecture. We are going to start complex numbers. Okay.